All right. So anyway, good evening, everyone. Welcome to the June edition of the Garden State Java User Group. Thanks for your patience in working out our technical difficulties. So without further ado here, let's get started. The agenda, of course, as always, is we thank our sponsors, talk about what's new. I'm going to introduce Rustam. And then at the end, we'll do our usual upcoming events and things like that. And then, of course, we'll give away a license of IntelliJ IDEA. So we're very thankful to have JFrog as our platinum sponsor, DevOps company. Check them out on jfrog.com. Our silver sponsor is Azul, makers of Azul Zulu. And they're one of the first OpenJDK downstream distributions that implement the coordinated coordinated something. Yeah, so CRAC, so something checkpoint. So DevNexus is our partner, and they have an awesome conference that's usually in the March-April timeframe. Next year's conference is in March 12th, thereabouts, that midweek of 2024, and it's in Atlanta, Georgia. Our per meeting sponsors is JetBrains. Of course, they're the folks who make IntelliJ IDEA, WebStorm, PyCharm, and all the other awesome IDEs that they put out. They're of course they provide the licenses for us to give away to our members. And Jakarta EE and the Clips Foundation, they provide hosting to Crowdcast, which we originally used when we first got started as the Garden State Java Group. So we always have that option to use that as well. All right, so what's new? I talked a little bit about this last month, about JDK 20. JDK 21 is now in ramp down phase 1. And what that means is that the feature set is frozen and is that there's no more features to be added. And from there, there's only bug fixes, and then the GA release will be in September 19th of this year. There are, I didn't update this. There were 16 JEPs, and it dropped to 15. The JEP 404, the generational Shenandoah, that was proposed to be dropped so that the Shenandoah team could actually make more improvements. Their reviews found that I guess they weren't too satisfied with what they would have had out for JDK 21. So they're going to drop out, and then they're going to target JDK 22, which will be in March of next year. But there are a total of 15, and there were more added to this list. Okay, so now I'm happy to introduce Rustam Mehmandarov, and Rustam is a passionate computer scientist, is a Java champion and Google developer expert for cloud. He's a public speaker, community lead, and mentor. And I'm happy to say that Barry Bird and I went and we picked him up at the airport today. Rustam will be going over to QCon New York, which starts tomorrow. So this was like perfect opportunity to spend some time with him and before today's meeting. So Rustam, welcome. So thanks for having us.
All right, thank you for the introduction, and thank you for having me. Thank you for making sure I don't get lost in public transport and traffic and all that. So today I would like to talk about modern Java apps, and I have a let me see, presenter view. Yes, there. Then we can go full screen. All right. So the thing I want to talk about is you can call it many different ways, but I try to pick up 5 different things to make your apps a bit more modern, a bit more I call them awesome, but it's all in all, you can call that a cloud native apps and what it actually needs to be a cloud native application. And also it is also a set of things that you should be able to find in any modern application, because typically we've been doing Java development 10, 15, 20 years ago. We were doing monolith applications without any of those or most of those things that I'll be talking about. And I mean, we still made it work. It was still okay. But nowadays with the cloud and cloud native and all these kind of things, we need a little bit more things to have in our application. So what are those things? Before we go to the 5 things, I would like to do a little bit of introduction, and also it goes really well with us developers starting counting not from 1 but from 0. So that's what I did. And I want to talk a little bit about mentioning the Java ecosystem. So whatever Java actually has in addition to being just the Java platform. So there was this thing called, it's been known under a few names, right? It was called J2EE, Java EE, Jakarta EE, and so on, so on, so on. I usually kind of ask when I do this talk or similar talks, I ask people in the room, how many of you have heard of J2EE? There will be some hands. And then I ask them, how many of you have heard of Java EE? There will be some other hands. That's funny enough. And then I ask them, how many of you have heard of Jakarta EE? And then it will be like a third set of hands. So it's kind of funny. And then you end up like, okay, look, all of you could have raised hands at the same time. It would have been actually the same group instead of being 3 groups, slightly overlapping. But the point is, Java, many other languages have batteries included. So they put libraries into their platform, into their language, and it's kind of easy to import. Java is a little bit different. So they put all those extra things that made your application development easier and made it a little bit more simplified. It was part of this thing called Java EE, Jakarta EE, whatever you call it now. Now we're going to call it Jakarta EE because that's what it's called now. But in that timeline, you can actually see things that were added after each other. And there's a lot of things that we use nowadays now. WebSockets, JSON handling, concurrency, batch, all these kind of things. JAX VS, for those that got to play around the SOAP back in the days. JAX RS, for those of us who are playing with RESTful services nowadays. And, all those kind of things are actually part of Jakarta EE. And I will be talking a little bit about some of those features, but also I'll be talking a little bit about a subset of those. So subset of those that now is called Jakarta EE10 core profile. And here you see a very specific set of things that are very related to cloud stuff. I mean, a lot of that, not all of it. There are things like CDI, which you kind of need no matter if you go with cloud or not, dependency injection as well. But then there is things like JSON processing, RESTful web services, all these kind of things that you would typically need in a modern RESTful application. On top of that, so there is a Jakarta EE10 core profile box that you see all the way at the bottom there. It was a subset of Jakarta EE10 platform. As you can see, there is a lot of things grayed out there as well. You can use them and import them and all that, but we're not going to be talking too much about that part because, well, I mean, it will make your applications more awesome, but if we have to pick some, we're going to concentrate on the core profile. And we're going to concentrate on things that are built kind of in addition or added to this core profile as well. So that's where the micro profile comes in. So you have things that you really can't create a cloud native applications, or at least will make things very different. You'll have things like configuration. You'll have things like health management, metrics, fault tolerance, all those kind of things that you really need to be having in your cloud native applications. I keep on saying that you need that, you need that, you need this, and I don't really explain why. I will do that in a second, but just bear with me for a little bit. There are a few things that, again, we're not going to be mentioning, and that is the standalone part of microprofile that is outside the microprofile umbrella. Those, again, it's the same thing as the previous slide. Those are really nice things. If you need them, you can import them, you can use them, but we're not going to be talking too much about those, or at all, actually, about those things as well. So what is important to mention here when we talk about all this is that all of those things, both Jakarta and microprofile stuff, is actually specifications. And they're specified in documents like this. This is a definition of core profile, for example, and the link to the documentation, you will, I mean, the links to the specs and all that, you will see throughout the presentation, somewhere hidden on the sides or on the bottom of the slides. This is up to providers to actually implement and claim compatibility, and it is up to them to actually say, hey, we are actually compatible and we support a specific version of that. So now, this is, I mentioned Jakarta, I mentioned microprofile, and this is not necessarily talk about only microprofile or Jakarta. I had to pick some kind of technology to show you how things work. But a lot of those things that I'll be mentioning, including fault tolerance, for example, that you see as a first of those 5 things that we'll be talking about, they should be available in other frameworks or whatever of your choosing as well. If it's a modern platform or framework, it should be able to support this kind of stuff. For example, Spring Boot can be an example. I will not be showing examples with Spring Boot, but you can find a lot of those similar things and similar technologies in other platforms as well, other frameworks or whatever. So the idea is to give you a taste and idea to what to look for at whatever you're using. If you want to use Jakarta and microprofile, that's perfectly fine and that's great. If you want to use something else, that's also absolutely fine. So what is fault tolerance? Let's talk about those 5 things. And after the introduction, fault tolerance is basically what happens when something you rely on fails. So you have an application, you're using some kind of endpoint, and you want some kind of data from that endpoint. What do you do when it's not happening, when that endpoint is failing, giving you an error of some kind, not responding within the correct timeout, or something happened? We've seen a lot of issues with this kind of things where we if you look at a lot of postmortems of failures or takedowns or some kind of failures happening to large providers or large systems, you often see that very often it's some kind of human error. That's one thing. The other thing is that it's also very often that there was a wave of things happening where systems would end up DDoSing themselves because something fails. The other part of the system goes haywire and crazy because it's not being able to receive something, so it keeps on sending more and more requests, and then the other part of the system starts failing because it's being DDoSed, and then more and more things are getting unresponsive and are not able to actually get the data to their systems. They keep on sending more messages to each other and more traffic and more overloading the network and so on, so on, so on, right? What can you do when things fail. And why do you want to do that? Well, one of the obvious things is that your application just simply crashes, right? It just fails. It can be an endpoint that you have control over, but it can also be an endpoint that you have no control whatsoever over. It can be a third party. I usually use an example of a weather app because, you have an API, you get a weather, and sometimes, well, that API is down. So then you can't get the temperature for a specific location, right? Sometimes you want to be able to handle that error gracefully. You just want to tell the user, look, something is wrong. Please come back later. We're going to fix it. We're going to look into that. That's one way. The other way of doing that is also trying to fail over to something else. So if you're thinking about the weather endpoint again, let's say you have a weather endpoint that is very precise, but a little bit unreliable. And if that one goes down, you can actually nicely and quietly go to another endpoint that is much more reliable, but maybe less precise, and pick data there from there and actually show that. Yeah, we talked quite a bit about DDoSing your own application because of the things inside fail and keep screaming at each other. How can you do that? So I'm going to show this, like I said, on an example of microprofile for this case. So on this case in particular, that's going to be microprofile fault tolerance specification. And according to that, there are a few things that you can annotate your code with. So there are things like timeouts, retries, fallback. There are things like circuit breaker, and also bulkhead and asynchronous that we are not going to talk too much about those two last ones. But the first four are very interesting. How many times is your application allowed to retry? How long do you have to wait for a response? And if something fails, can you define an other alternative endpoint? I have created an example and I have some code that I'll show you live, but for now, just to go through all those 5 points, I have some screenshots, but we'll see that code live in a second or at the end of this talk. So if you look at this now, we have a RESTful application that is running on localhost port 8080. We have this. We have an API URL, so /API, and that one offers two different messages or different messaging services. So there is /message, and there is also a message backup. And what we will be doing now is that we actually are able to define a failover from one to another that you can see here. So you can see it, /message will run get that data method. You'll see get that data method in a second. And if that fails, we defined a fallback method to be get that other data, which is the message backup service that is at the bottom there. So what I've done is to create an endpoint that will be responding at API/message, because this is, think of it as a front end for your application. It's not front end in the sense of HTML and CSS and stuff, but this is a REST client. So this is something that talks to another REST endpoint. And this is, think of this as a backend for your REST client. So your backend of your REST client defines two endpoints, right? It has API message and API message backup. As you can see, on the left is a message, on the right is a backup. So this is actual implementation of those two methods. So message backup returns a message saying a backup hello, And the message itself says hello there. But if you look a little bit closer, I have done some stuff in the method for the regular method. I roll a dice, and if the dice is, yeah, if the number you see on the dice is divisible by 2, you define a success. So you actually run and it works. If it's not divisible by 2, your method fails. So it should fail roughly half of the time, right? But then there is some randomness and everything, so it's not going to be every second time. So if it is a success, it returns a response okay, and if it's not, then it will just return you this thing that you see at the bottom saying some weird error. The cool thing is I don't have to do anything else than actually defining those 2 endpoints. And in my client, I can just create at fallback, say where it should go, and it will just automatically work. And we'll see a demo of this in a little bit. Okay, let's talk a little bit about health. So we talked about handling failures, but we can also talk about what happens inside your application. So how do you actually look inside your application and just open that box and see, hey, are you doing fine? How's everything inside there? Yeah, I'm really sorry for that really bad pun at there. But this is I know I should be, but I'm not. But it's because I'm full of those bad puns. Yeah, so basically it's checking up on your application. How is it going? And you can do it, or you should be actually able to do it in different ways. Because if we talk about cloud native applications, we need to think that there's a lot of things that are actually happening when you invoke your application. So in a good old days, you would have an application server, your monolith running there, and the call would come in, it would just answer and everything is good. Now we have things like, I don't know, let's say serverless, we have containers, we have all this kind of stuff. So imagine you have a serverless application, and the whole point of the serverless that it can actually, well, you don't have to manage it. And if you don't have to manage it, it might most likely scale down to 0. If it does scale down to 0 and the request comes in, there is a lot of things that has to be happening, right? Your application, something has to receive the requests, understand where it goes, understand which application is responsible to that, understand which container image is responsible for doing that, go and pick that from a container registry, deploy that container, start the application inside the container, and then actually process the request and return it back. So there's quite a lot of steps that you don't really see when this happens, and you just think, well, it should happen like this in a blink of an eye. To do all that and to be able to know when you should scale your applications down, up, when it is ready to receive requests, when it's not, all those things, that's where the health comes in. So you need to know when the container is running. You need to know when the application inside that container is running. And you need to know all that for handling requests, but you also need that to, sometimes you need that to know whether you should scale up or even down, and how fast as well. For that, we have a few concepts that we should know. And again, this time I will be showing this on an example of microprofile health specification. But like I said, it doesn't have to be microprofile. Choose whatever you want. Spring Boot, Micronaut, there are different ways of doing that, but you would typically expect that because This can be plugged in directly to things like Kubernetes. So Kubernetes will look for this kind of stuff, or I don't know, cloud, Knative, Cloud Run, you know, all this kind of things. They would look for things like this, for readiness probes, for startup probes, for liveliness probes. Liveliness probes actually is the one that makes sure that container is responsive. So if it's not responding on the liveliness probe, typically Kubernetes will take down the container and recreate it and see if it starts responding again. If not, then you know it will do its thing and try to bring it back to life. Readiness and startup usually help to decide whether you are ready or not to receive requests, or whether you're ready or not to take down an instance if it's being used and processing some kind of request. Then, well, then you probably should not kill your container, that instance. Another thing that I want to talk a little bit about, and we'll see again in a little bit at the end when I'll be showing you demos. I'll show you how to implement the simple ways to do this kind of probes. So now I want to talk a little bit about metrics. And metrics, it's kind of connected with health, but it's a little bit different still. I mean, otherwise it wouldn't be two different things. Metrics let you define custom application metrics and expose some kind of specific information about application that is not, hey, are you alive? Hey, are you ready to receive requests? Hey, is your database up? You know, all these kind of things, that's health. Metrics is more like, okay, how many requests have you processed so far? Or how many are you doing a second? Or how many failures have you been having? You know, all this kind of thing. It lets you expose those on a standard endpoint, so /metrics, using standard formats. And that can also be fed into things like, I don't know, let's say Prometheus or something like that. There are standards that are being agreed on that are, and they are being supported by, in this case, MicroProfile, and there also can be read by other tools to do something about it, to do logging even, just simply as that. Like I said, it's being used to measure custom parameters. It is very often very specific to your application. Typically, MicroProfile provides a bunch of metrics out of the box, but you can also implement your own. And the way you do that is, again, with annotations. And annotations quite, I would say, quite logical build-up. So you do, for example, you do counted. Well, it's supposed to count. You give it a name, you give it what kind of value, if it's absolute or not, and then you can also provide tags. Tags you need to, we'll see that in when I'll be showing you a demo. That's a way of differentiating different, for example, different methods contributing to the same value. But then you can also say, for example, one of them would be tag failover, and the other one is the original. Like if we think of the method and the backup method, you can actually count it on the same value, but you can tag it with different things. So backup and mainstream, whatever you want to call it. Like I said, it's gonna get exposed, gonna be exposed at /metrics, and it's probably a very good idea to make that URL available inside your network or inside your application perimeter, but probably not a very good idea to make it available for the whole world. So be careful a little bit about this kind of things. Another thing that I want to talk about, thing number 4, it's not a MicroProfile thing. It's not even a Jakarta thing, but it's more of a thing that you should be having for as a tool. And I'm going to show you again, I had to pick something. So I'm going to show you an example of a tool called Unleash, but you can use anything else. as well. Any other tool that does feature toggling. Technically, I was doing this talk some time ago, and somebody asked me, "Hey, can we do that just with ifs and else's?" Yes, you can, but that's not the point, because if you do all those if and else's, you have to do a lot of handling of this stuff yourself. With the feature toggling, you outsource all that to a server. It will do all that, and then you can just tap onto that source and see if something is on or off. I'm going to show it's called Unleash. Unleash, it's an open source product. That's why I'm talking about that. But they have like some kind of commercial offering that I don't talk about. But I mean, they have like their own cloud stuff, and they have enterprise version and all that. But the other one is just basically GitHub repo where you go and clone it, and you do Docker Compose up, and it's just up and running. And it lets you. I have it everything running, so I'll show you in a bit. But the idea is you can easily flip features on and off. And why do you want to do that? That can be also different reasons. Sometimes you develop something and you're not done. So for example, you've developed front end, but the back end folks were not fast enough. They're not done. What do? You kind of create a new branch? Do you remove it from your front end? Do you do that? The easiest way is to introduce a switch, turn it off, keep it there, but do everything you have to do. When you're ready, you just deploy a new backend, everything, and then you flip a switch, and then the feature just magically appears. And that can be used both on the front-end side and back-end side. And now I'm actually talking, I know I've been confusing you with all this front-end and back-end. Now I'm actually talking like web front-end and back-end service kind of stuff. It can also be used for gradual releases. So maybe you want to say, hey, I want to release this feature to 5% of my users and not all of them. It can also be used for geographical things, like everyone from US, everyone from New Jersey gets this feature, everybody else has to wait, something like that. There is also one kind of, there's the link, by the way, to that tool that I was talking about at the bottom there. There are a few things like, how do you want to do that? But how, right? Well, you can do it by hand. You can code it with ifs and else's, of course. But then you have to handle all that. You have a lot of legacy code, very fast, some kind of technical depth just lying out there that you don't really want. You can put it in a config file like we did in good old days. We would like put things on a JBoss with the config files and everything, and it worked. Yes, you can. But then you can still, if you want to deploy new versions, you probably need to restart your application. You need to restart your app servers, all these kind of things. It's not really fun. It's kind of tedious and boring task. So the good idea is to use a tool. But then there is also a thing that you need to think about. You still have some toggles and stuff in your code that you really need to remove at some point. Because I always think of this example. I don't remember. I think, and I probably might be wrong, and it's kind of sad because it's on the recording, but I've used this example before, so this is fine. I think it was a server of British Telecom, and they were moving from one location to another, and they had like a big server room of machines. So they moved all of them, and then at the end there was a server, old machine in the middle of the room. Nobody knew what it was doing. It was just on and blinking, and nobody really dared to turn it off because, well, it's been there for 50 years and we don't know what it's going to be. Maybe nothing will happen. Maybe everything is migrated from that thing, but maybe it's just going to take down everything and nobody will be able to call anyone. This is what happens when you have a lot of legacy that is not well documented or actually not cleaned up. If somebody actually migrated things from that server and turned it off when they were done, we wouldn't be in that trouble. The same goes with features. If you don't clean up at the right time, you will end up with a bunch of features that you don't know if are being used or not. You don't know if you should be able to clean them up from the endpoint that is toggling those features, but also there will be a lot of code that will be probably dead code because you need to do some kind of handling of those features and on the backend side as well. With that said, I want to show you real quick how you can actually do that. So I have a very, very important toggle in my code, and that's what I meant, but that you need to handle. You need to have some extra, a little bit of extra code on how to handle your features. So for example, here I do if unleash is enabled, and then I provide a name for that feature, which is called chaos. I do something. If it's not, then I do something else. So I initialize a string message with a message, it's a bug. If the chaos is on, chaos feature is on, the bug becomes a feature. So, you know, it's not a bug, it's a feature kind of thing. And then the way you do it, you just flip a little switch that you see the purple little switch at the bottom there, enabled in development. And that's how you flip it on and off. And this is pretty much all the code that you need, in addition to a little bit of initialization. Oh God, that's a really hard word to pronounce with jet lag. I mean, it's just for the record, it's what? It's, let me see. Yeah, it's 1:30 at home at night. So, you know, it's getting there. Okay.
So.
Yeah.
Back up a sec. I'm not seeing how this is that much different from manually having if statements in your code.
So I'll repeat in case this is not easy to hear. So Barry's asking if it is how is this different from just regular if sentences in a code. The thing that is different here is that you don't control if it's on or off. You just say if it is on, do this, but you actually have an option to control it outside in a third application, right? Yes, Chandra.
So in addition to that, you could reuse the same toggle at multiple locations.
Oh yeah, that's
streaming it across, controlling a lot of different features with exactly one toggle.
exactly.
Right? So for instance, the canary mode that you're talking about,
Yeah.
Geographical or I guess type interface, you could put it across different features using the same toggle. That's one thing.
And also, yes, it's a very good point from Chandra as well. So you can, I'm just going to repeat it because the microphone thing is here. You can use the same feature to control, or sorry, same toggle to control the code and different parts of code and different, even different applications, different parts of application, or even actually front end and back end. So technically it's probably two different applications, right? Yeah, and also you can, for example, toggle things in develop or different environments as well. And again, this is just an example of a tool like this. There are a bunch of other tools like this, but you can expect similar behavior from those. One last thing I want to talk about, and this is the kind of a little bit of my pet peeve sometimes, and this is about, you know, we're talking about making our applications more awesome, and we talked about how we can make them awesome, right? You can make them more cloud native, you can add health, you can add fault tolerance, you can add feature toggling, you can do all this kind of fun things. One last thing I want to talk about is that all of your applications still need to run somewhere, so they need some kind of environments. They need to be configured somehow, so they need to have some kind of way of providing that configuration for different environments and stuff. And you need to run it on some kind of infrastructure. You need to control that infrastructure somehow. It may be physical, it may be virtual, it may be something else, but you still need to control that. First, one thing, and that's a very important thing, and you probably need to repeat it. I wish people actually would repeat it every night before they go to bed. At least print it and put it on your wall or maybe ceiling. When you lie down, you can actually see it. And, prepare yourself for the text. That is the text. And that the text is stop doing click ops. So in case you don't know what click ops is that, this is basically configuring stuff. It can be, configuring your cloud instance. It can be configuring your favorite application, configuring your favorite framework, whatever, with clicks, point and click. Don't do that. And by not doing that, you will gain a lot of positive effects. And the positive effects of that is that you actually get to document your process. If I set up a environment and do it with ClickOps, I'm pretty sure if somebody else has to set up the same environment, it's not going to be the same, because maybe that person will find another feature or another setting or forget another setting or do something like that. You do not have, and it will take a longer time to set up environments, configurations, all this kind of stuff. Another thing is that, so that's the documented part. Another thing is that it's reproducible. If you want to create a test environment to test something, and tear it down when you're done. In a month, you can run the same script and it will create the same test environment, and it's going to be reproducible. The other kind of obvious thing, a little bit of a Captain Obvious to the rescue kind of thing, is it's going to be automated. And it's not going to be, you don't have to do the boring stuff over and over and over again. Then you can actually implement all the bugs or the features. No, I don't remember which one it was, but you can do that instead of actually setting up the environments and all that. The downside is it's not shoot and forget. You actually have to maintain. That thing needs time, care, and love. You really need to make sure that it actually runs every time. If it fails, do not, we have to go this. If it fails, do not do ClickOps. Do not fix that with ClickOps. Fix your script, rerun it, and make it sure it actually works. So what parts of this applies to what I was talking about? So there are a few things, right? There are things like infrastructure as code. And there is different approaches. For example, Terraform and Pulumi, they have slightly different approaches. One might even say that one of them is declarative and the other one is imperative. In reality, they are not, but that's a different story. The point is, pick something and use it. If you like Terraform, go with Terraform. If you like Pulumi, go with Pulumi. If you like something else, go with that something else, but make sure that it's actually, you're able to create a script and describe it and actually commit it with your application so it can also be versioned as well. When it comes to configuration, you need that to, for example, make sure that different environments have different IP addresses for different services, or different names, or different something that is different from one environment to another. You need to handle configuration files. You can do that by hand. You can obviously read and parse text files. I know, I'm pretty sure most of us can do that, but maybe you don't want to do that again. Maybe you want to use a specification. In this case, there is a thing called microprofile config specification, but There are other ways of doing that as well. I mean, people have been doing it for quite some time. There are libraries, and no matter how tempting it is, don't try to write one on your own. Probably not a good idea. Probably. When it comes to infrastructure, I want you to think about a few things, and that is which kind of infrastructure you want to run things on. Is infrastructure as a service is a thing for you? If platform as a service is a thing for you, if you want to go serverless, or if you just want to go good old rent a VM and compute and some memory and disk space and actually create a VM and run everything on that VM. Your application will tell you what it needs, or you will know what it needs based on what your application kind of the specs of the applications are. But pick something, stick to that, and actually do critically evaluate, do you need that? And if you think that no matter what, you're good and you're fine with Kubernetes and just set up a huge Kubernetes cluster and just run your tiny little application, it's probably not. And the chances that you are as big as all the big cool companies that use Kubernetes and brag about it, well, maybe it is. Maybe your application is super small and you don't want to use all that money on Kubernetes clusters. Maybe you want to go, I don't know, serverless, or you want to go functions, serverless functions, which is even smaller kind of piece of that. There is also another thing that I didn't put on the slides, but there is also this thing that when you create infrastructure as code, that's cool. But then how do you actually maintain setup and push the updates and all that? So let's say you create a bunch of VMs. You need to maintain those VMs. And that's, I don't know, if you want to use, I wouldn't use Terraform for this kind of stuff. So then there are tools in addition to that. There are things like, there is a Salt Stack, one of them. There is Ansible by Red Hat, another one. And there are a bunch of other things that you can use to keep on configurations and things running. You can also, you have to think about where infrastructure as code borders stop and where the kind of, okay, now we're going to do maintenance or whatever is running, starting. And think about that and try to define it and try to separate it a little bit. So that's pretty much it. And this is a demo time. And let's see. So what I have is, I'm going to show you containers first. So I'm going to be running everything on, well, all the commands and everything will say Docker, but in reality, I'm going to explain you why and how it works. Let me make it bigger. So in this case, I'm actually using Podman, but that doesn't matter. You can use Docker, you can use Podman, you can do anything that runs Docker files. My setup is easy. I have two different small groups of containers. So 5 features talk demo, that's one group that has a web service client and web service backend. And then I have another little cluster here of Unleash things. So Unleash have a web front end and database, but that's Unleash thing. That's not really important. That's one, we can look at it as a one box. Also, as a, oh, perfect. It actually switched to the right screen. That's good. Let me go into presentation mode. So like nerd that I am, or geek or whatever, I don't know, there is different definitions and stuff. I did create a UML model-ish model, at least a model of my application, and I created that in ASCII. The way it works, the way it is, I have a service 1 that is the client, and I have a backend service that is the backend for the client. the front end or the client service has two endpoints. It has hi and feature. The back end has hi, feature, message, and backup message because, well, you remember we talked about those. Each of those boxes uses some features from the feature toggling service. So for the client, we have a feature that we're using. The other one is using feature, chaos, and delay. All right, let's start with some, let's see. I want to go to, let's start from the beginning, right? We can do, okay, no, I can't. Okay. Is this, should I make it bigger?
Let me take a look at it.
I can do like this.
Yeah, that's probably.
That's probably better. Okay, so we kind of move this thing. So like I said, we have two different services here. We have a little compose file that defines all that. I define some dependencies to different services. I say, well, you can't start one service without the other one being there, and all this kind of stuff. I define my own little network. So actually Unleash and all my containers are, I can start them with different Docker Compose files, but they can still talk to each other because otherwise they end up on different IP ranges and they're not able to see each other and all that. But this is a little bit of a technical setup. The fun part begins here. See? So this is what we've seen a screenshot of earlier. We have a we create a REST client. We point that REST client to the backend service. This is on the client side, right? If I try to locate this file, you see it's in the service folder, not in the backend service. But the backend service will be running on backend 8080, and I expect the message and backup message be there. And if backup message is not there, it will fail over, right? Let's see if this works first. This is wrong. Window, this one. So 9081, that's our client. We go hi. So it says my fancy message class, message hello there. And if I just keep on refreshing that, nothing will happen. I need to make that bigger, right? Nothing happens. And why is that? Well, that's because we have a feature called chaos. Let's have a look at that one. We have inside the application here, we have a message, and to make that message work, it will always say hello there, and it will always give you a success because we have not enabled this chaos variable. So what happens is that this is Unleash, this is how it looks, and this is the features I have. For now, I have only one feature, and that's called chaos, and it's off. So if I turn it on, it's on a different server, right? And I go back, and then I refresh. And now we're actually introduced the failing thing into our code. So sometimes it will go back up, and refresh. Yeah, that has failed. Refresh. Yeah, now it's back to, yeah. So you see, it keeps on flickering. And that is really good because now our application is actually failing, but if it was the same text, you would never actually seen that it's failing, right? This is failover, and this is what you see being defined here. Another thing I want to show you is actually how do you instantiate the unleash. So in this case, we're using unleash. This is all you need to do. You create an object where you provide an API URL, you provide instance ID and all these kind of things. And also you provide an API key. And that API key, by the way, that you see there, that's the default one. So it's actually safe to show. You probably don't want to show your private ones because otherwise everyone can control your stuff or read configuration from your stuff as well. After you've done that, and actually, by the way, this application is running on Quarkus, and there was it did not really work well with Quarkus. There was a little bug that kept on refreshing and recreating the config object, and there was a bug. I submitted that bug, and some days or week later, it was fixed. So that was actually really nice. So now it works really well. And whenever you need to handle those features, you can just say unleash is enabled, and then you provide a feature name. So I want to show you actually how easy it is, because now we've been looking at high. I want to look at feature, right? It's actually keep on saying it's a bug all the time. But that's because we don't have actually a feature called, what's it called? Feature, actually. Feature. Good. So we can create one. We go there, create new feature toggle. We call you feature, yes. We're gonna do, yeah, experiment is good. Create feature toggle. All right. So it's still a bug, right? But do you have 2 minutes to help us? No, not right now. I'm doing a talk. I'm sorry.
Don't they know that?
I know, right? I mean, with all the cookies and everything, they should have known that. Anyway, now you see, I created a feature. I turned it on in development, and within 10 seconds, it should be available. So while I was kind of entertaining you with talking, it should, yes. See, it's a feature now. And then if you go back, turn it off. I mean, if you think it looks different than what you saw earlier, that's because I zoomed in. So if I do like this will be back to the view it was. But then this will be small. But yeah. Now it's a bug again. So this is as simple as that. And those kind of feature toggles you can have, like it's been mentioned already, you can have one feature toggle for many different things, and all of them will be turned on at the same time. If you need to, that's really nice.
So
Yeah, very.
I assume that I can have more than 2 switches development and production. I can make finer distinctions.
I think, well, normally, yes, you can. And like when it comes to this product, that's the standards stuff that comes, and there are a few things that I'm missing. So one, I really would love to have more environments, and the other one would be to have more projects. Right now, it has only default project. I haven't checked. I will have to check this if it is just not set up, or it's because some of those things are kind of enterprise features that they don't want you to turn on. Toggle Z. Okay. Yeah. That's really nice. Okay, so Chandra is saying that there is also a thing called Toggle Z that you might want to check out. I mean, I picked Unleash because it was open source, and it was also because it was made in Norway. So, you know,
There you go.
there you go. So you just had to do like shameless plug of Norwegian software. Made on hydroelectric clean power with unicorns and well, no. No unicorns were harmed during the production, I think. Okay, let's go a bit further. How are we doing on time, by the way?
Well, it's 20 minutes to 8, and we have to be on the train or get you guys on the train.
At 8?
In 40 minutes, is it?
Oh, yeah, that's fine.
8:22.
Yeah, okay, so I have another 39 minutes to talk, right?
If you can run very fast.
Now we'll be done very soon. I want to show you a little bit about health. So first I'm gonna show you how this looks. So if you go health, the jet lag is killing me. I can't type anymore. So soon I will stop being able to speak. So health, yes, there you go. So health is actually pretty cool. So I mean, I have a plugin that parses JSON and makes it pretty. If you want to see it raw, that's how it looks. If you want to have a little bit prettier version, that's how it looks. Just so you know. But as you can see here, 9081, that's the front end, and front end has quite a few liveness probes and some readiness and some startup. If you go in the back end, I did not implement that much. So there it's just, well, application started, done.
One of the things that I've noticed when we do health checks,
Yeah.
a lot of people go service intensive health checks,
Yes,
and that could also cause further performance issues in your application.
that's a very good point. So service intensive, it's probably not a very good idea to do service intensive health checks because, well, it's going to influence your performance, and that's totally correct. But sometimes you just need to, you definitely need to think about that, but sometimes you can't really do anything about it. So for example, sometimes you want to ping your database and see if it's up and running, and that's a call. That's technically you're stealing a call, but it depends on how often you do that as well.
Would that be on a separate thing that just happens?
Yes.
Registers the state, and then you read from that state on a periodic basis from your license?
Yes, you can, for example, do threads. You can implement it as threads, but the good idea is to try to do it the same way, at least in my book, to try to do it the same way as the rest of the application will be behaving, because otherwise you're testing something that is not users going to be using. So, you know, and then then you need to consider how often and how fast and how, you know, all that is happening. But simple health check, the one that you saw on the back end, that's how it is. You just do application started up, that's all, right? Liveness response code check, that's kind of fun. You can already start doing some smartness. You can start doing verifying response codes and say, oh, if I get 200 from that endpoint, well, then we're good. And if not, well, then critical service has stopped responding. Hey, we need to do something. Restart it, kill it, start it again, you know, do things. And also you can actually verify and do some different kinds of exceptions and, you know, handle it in a different way. Here I throw the same error message no matter what. So IO exception or wrong response code, it will give you the same message. You can actually change those. The fun thing you can actually do is that you can also do response time thing. So that's another liveness thing, right? If your application is not responding within your SLA or your whatever, you can actually do something about it. You can log, you can raise alarms, you can do a bunch of things. And to do that, I have created another toggle that we need to create. I didn't want to create them beforehand simply because I just wanted to show you how easy it is. There is something called delay, and delay is quite fun. So if you search for delay, there. So what happens is that this is, it's inside of still the message call. I have a toggle called delay. And if it's enabled, it basically takes a power nap for 5 seconds. You know, we all need a break sometimes. I mean, I had a lot of bad pun day when I was writing those comments, but yeah. I mean, it's bad. But anyway, sleep for 5 seconds, right? But our liveness probe here, let's see. Our liveness probe here actually expects to be at less than 3,000 milliseconds. So 3 seconds. And now that I have delay here on, come on, stop asking me for the feedback. I'm busy. Not right now. Okay, turn it on. And then let's have a look. You see, it's not really responding because now it actually has to wait for 5 seconds to get the response because my message, the one that is actually testing, is waiting for 5 seconds before it replies. And yeah, it says an error. So if you look at the index 1, so second one, it says aliveness critical service high is too slow. And that is the message that I have put here. So I actually say which path it is. And so I check them all and test them all. And then I just say, well, look, that one is actually slow. Readiness is another one. Readiness is actually its a way of doing that. This one is very simple. I ping a server. I just do service and a port and host. And if I get a ping back, it's fine. If not, not. You can do it, for example, also by pinging a database or trying to call a database or something like that. What else I can show you? Okay, we've looked at, metrics is fun. Let's have a little bit of fun with metrics. So metrics, you see all that text? You see all that wall of text? Well, yes, it's a lot of text. No, you're not supposed to read it. That's tools are made for reading this stuff. But the important thing is that my backend server has introduced some special metrics that I have created, and those are those two here. So that's one of them is actually saying, trying to count the number of times I actually invoke message endpoint, and I created a tag called purpose total, but I also have I also count the number of failovers there as well. And to create this, to actually have, because all the other text here that you see is the standard stuff that comes with the metrics endpoint. But those two, like I said, those are custom stuff. And this is defined see. What was it called again? Purpose. There. Yeah, no, come on, yeah, there. So the way I did that, the way I do it in MicroProfile and the way you can do it in other tools, it probably will be different, but here you just do counted, you give it a name, you say if it's absolute or not, and then you create an add a tag to it. And that's it. And that's and all just by adding that annotation, it would create you this thing. And if you see it, now it says 19 failovers and 63 invocations in total. If we go yeah, we can use slow. And we should probably turn off the delay because it will drive us crazy. There. Yeah, so now it failed already once. So now it should be at least 20. So 64 invocations and 20 failovers. That's what it is, right? So it worked. And that's the point is, you just add one annotation and just rest is handled for you. That's really nice. All right. What else? Feature toggling, we've seen enough of that. Environments configurations that we've seen quite a bit about that. There are some links here. I think that's pretty much it, because I mean, I can probably show you a lot of things here for a long time, but we need to catch our train. So the most fun thing was to set up the Docker Compose and making sure they all kind of talk to each other and everything. Chandra, question.
Is this code available on GitHub?
It will be available. I've promised to make it available many times, and I will make it available. It's a private repo right now, but it should be actually open repo. So I'll open it up, and then I will let everyone play with it. Yeah, and then you can actually look at the Docker files and stuff like that. There are some cool things that happens in Docker files as well, because this is outside this talk, but I'm going to mention it anyway. You see that weirdness that is happening in the beginning? Like, why don't you just say, one thing is like it's a multi-stage build, right? So there are two steps here. One where you actually build the artifact with Maven, and two where you actually deploy it with Quarkus and all that. That's one thing. That's fine. But there is also something weird happening with where you do Maven verify -b never fail. Then you actually copy stuff, and then you do Maven package. Any guesses why? This is really weird when you look at it, but then when you realize why, then it's actually, maybe there is a better way of doing that. But this is, okay, I'm going to give you a hint. Layers. So if you just do Maven clean install, Maven package, clean package, whatever, not install. Every time it will actually download the whole internet every time it builds everything, because it creates a new layer and it just keeps on downloading that all the time. But when you do Maven verify first, it downloads all the packages, and then you copy your application, because it will download the same applications and it will be the same, right? But every time you copy your changed application, and if you do it before doing Maven build, it will consider it as a changed layer. So then it will be doing the jet lag is killing me. The point is, if it would have been like this, you would be doing Maven package from changed layer every time, and it would be actually thinking that it needs to re-download all artifacts all the time. But when you actually download all artifacts first, then copy your application and then build it again, then it actually yes, it uses the local cache of the layers and stuff. But I mean, it's more of a Maven stuff, but Docker stuff. But it's interesting things to think about to optimize and make your containers and your builds run faster. All right, I think we should call it a day, and we should say thank you all for joining in. And if you want to find me or ask me for any questions or anything, that's where you can find me on Twitter, and you can also find me on other platforms as well. Ping me. Feel free to ask any questions or anything. I'll be happy to answer. Thank you all for being here.
All right.
Come closer. You're
So we gotta catch a train at 8:23, and it's Rustam, how to get over to the slides? I'm gonna do this relatively quick,
Oh, yeah,
folks.
that's right. Let's see. There.
There we go.
Slideshow.
Okay,
There you
great, thank you. All right. So upcoming events, you've seen some of this before. QCon New York is the one I mentioned that starts tomorrow. I'm going to be a dedicated reporter. Rustam is speaking with Don Rabb on Wednesday. So, and then you have the others here, KCDC and EclipseCon. Java 1, well, we're not quite sure about the status of Java 1, and that's all I'm going to say on that. And Jakarta 1 in December. Upcoming meetings, we have Frank Greco next week, next month, right? Like I said. And then September is going to be a little tricky. Don't believe that September 12th date just yet. We're trying to move that to the 19th. We have some special things going on that particular week. More information on that. And Matt Rabel's going to make the Philly, New Jersey, and New York visits in October. And we need to decide on a presentation that he's offering. And then these are some of the other folks we are pursuing to, come speak with us. And so these are just the friends of JSJUG. And for most importantly right now is our giveaway of IntelliJ IDEA. Please scan that. I'll leave it here for a couple of minutes. While we wrap up. There is one question on the chat, and this has to do totally unrelated to tonight. It is our old friend Paul Furbacker. Let me go get my phone and I'll review the.
I will read it out,
Oh,
or I can yell it.
okay,
No, you better get your phone.
okay. All right. So Paul is doing an app for a swim club up in the Boston area. And he has a question about JPackage, not JPackager. So after quite a few years, he has to update this Java FX-based swim meet app. He can't get the org.berYX.runtime Gradle plugin to work, and no one has responded to my Stack Overflow question. And he is looking for some answers. So he typed his question in the chat, but I wanted to point that out to you and bring it to your attention. His email is PFURBACHER at mac.com. And if anybody has any.
If I may suggest.
Yeah.
In a follow-up email, you can just include this question and his contact me.
Okay, maybe I'll do that. Yeah. So, yeah, in any event, yeah, I could do that as well. I could put it out to the distribution list and, go from there. So, if anybody has any, can help Paul out, that would be awesome. So, in any event, so we look forward to seeing you in July, same bat time, same bat channel right here at the Dorothy Young Center for the Arts on July 18th with Frank Greco. So take care, folks.